Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 19. Doing real GMAT problems can really help you accelerate your growth quite a bit. So let's talk through a few examples together. The problems that we're going to go through are from the 11th edition of the official guide, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through these questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap. The official guide contains retired problems that have appeared on real past GMAT exams, and the exam is designed to change very slowly over time. So these are going to be very representative of the kinds of questions you're going to see on test day. I'll give you a chance to work through the solution on your own if you want to, and then I'll discuss my thoughts on the problem and my recommendations for what to take away from each one. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head, especially if you're on the go, but just do your best. If you are in a situation where you can physically write down what you would on test day, like on a plane or a train, that works great. Let's go. This is problem number 64. There are two sets of numbers. Set A is 2, 3, 4, and 5. Set B is 4, 5, 6, 7, and 8. I'll read those again in a moment. The problem says two integers will be randomly selected from the sets above, one integer from set A and one integer from set B. What is the probability that the sum of the two integers will equal 9? Let me read the sets again. Set A is 2, 3, 4, 5. Set B is 4, 5, 6, 7, 8. The question says two integers will be randomly selected from the sets above, one integer from set A and one integer from set B. What is the probability that the sum of the two integers will equal 9? Option A is 0.15. Option B is 0.20. Option C is 0.25. Option D is 0.30. And option E is 0.33. I recommend pausing here and at least visualizing the solution if you're not able to write it out. Probability and counting questions aren't the most common on the exam. We've already gone through about 60 questions together, and I don't think we've really touched on either topic much. But you'll see usually 1 to 2 of each of these topics per test. So it's worth understanding the basics, even though it's not going to be like the major bulk of your quant section. So that's what I'm going to focus on here. There's plenty of advanced approaches for probability and counting questions, and those have their place for sure. But for now, let's just keep things simple. The basic definition of probability is outcomes we want divided by all possible outcomes. And probability is generally expressed as a fraction or a decimal because of that. Outcomes we want divided by all possible outcomes. Again, there are many more ways that are advanced to calculate this, but one of the simplest and most useful ways on the GMAT is just to count the numerator and the denominator individually. So that's what I'm going to demonstrate on this problem. I'm not saying this is the only way to do it. This is just a viable way to do it. So let's start up by counting up the outcomes that we want. Sometimes there are lots of desired outcomes, but here there aren't that many numbers. There's only 9 total numbers in the entire problem, 5 in set B, 4 in set A, and there are even fewer pairs that sum up to 9. So manually counting is not going to be a big deal here. In fact, those are usually the best situations to manually count things rather than using like a slick approach. The slick approaches usually work when there's like 1,000 outcomes or 5,000 outcomes. That's where you're going to want something a little different, a little higher leverage, and I'm sure we'll get to those tactics down the line. But for today, I don't want to confuse the lesson. I just want to keep things simple. So What I mean by manually list and count is just think logically and list out all the possibilities by hand. I found this to be a really good approach when there are fewer than 20 possibilities. So if there's fewer than 20 possibilities, this is usually a good way to go. Again, if there are more than 20 things you'd have to manually count, you'll usually want to look for a pattern or use some kind of advanced tactic. But we've got way fewer than 20 ways to get a sum of 9 in this problem, so I'm just going to list them out, and I recommend that you do the same. It's usually easier, it's usually less complicated, and that typically means people are less likely to miss questions they know how to do. And if you've been following this series, that should be most people's main focus on the quant section, although it rarely is. As you might imagine, most people's main focus on the quant section is I got to know more stuff and complete more problems. And of course, that has its place. But if you are just focusing on knowing stuff and completing more problems, but you're not getting credit for what you know, then by definition, your score will not represent your true ability levels. And that's why I'm here right now, because I don't want that to happen to you. So let's start with the number 2 from set A. How many numbers from set B can we choose that will sum with the number 2 to make 9? There's only one. 2 from set A and 7 from set B. So that's going to be one of the quote-unquote outcomes that we want. And I would probably on my paper just write 2 plus 7 and then circle it or write the number 1 underneath it or something like that. We can't make any more sums with the number 2 from set A, so let's move on to the second number in set A, which is 3. And once again, there's only one number in set B that will create a sum of 9 with the number 3, and that's the number 6 from set B. So there's one more quote-unquote outcome that we want. If we choose the number 4 from set A, we can make a sum of 9 using 5 from set B, but no other numbers work, so that's the third desired outcome or outcome that we want. Lastly, we can choose 5 from set A and then choose 4 from set B to make 9, but there are no other ways to get a sum of 9, and so our total number of outcomes we want would just be 4, and I would write 4 in the numerator of my fraction, which would represent the probability, which represents outcomes we want over total possible outcomes. Now, all we have to do is compute the total number of pairs of numbers that we can pick. And that's going to give us the denominator of our fraction, and then we'll have the answer to the problem. So I'm probably going to mention this a few times, but there are fancy ways of doing this, and those are definitely worth knowing. But if you're just getting going with your GMAT prep, it's one of the worst things you can do to try to learn some really advanced tactic for a topic that's not going to show up very much. Maybe that's obvious, but I think it's just good to be reminded of that early on in our prep. You're like building a house, or you're building like a skyscraper with your GMAT skill set here and your business skill set in general for most of us. And we want to have a solid foundation. If we're not solid on the fundamentals, all the fancy stuff in the world probably isn't going to lead to the outcome we want. So again, I'm just going to talk through some of the basic concepts behind those fancier strategies that you will probably want to get to eventually. Just now is not like the best time in your prep to learn those. But if you're already deep into your prep and you're just doing this to brush up or gain an edge in your free time, then some of the basic concepts I'm going to talk through here hopefully will help you understand some of those more advanced strategies that you may have learned a little bit better. And I found that when we understand the concepts behind these strategies, we usually can make better use of them. So let's think about it systematically. If I choose 2 as my number from A, how many possible sums can I generate using all the numbers in B? Remember, I don't care what they sum to now. I just want all the possibilities. Well, if you just think about it on a basic level, I can do 2 plus 4, 2 plus 5, 2 plus 6, 2 plus 7, and 2 plus 8. Those are all the viable choices using 2 from set A. So I'll count each one of those as one of the total possible outcomes category. And that would be 5 total possible outcomes that I can make using the number 2 from set A. What if I start with 3 from set A? You might realize that I will be able to make 5 sums that way as well. 3 plus each of the 5 numbers in B. So that's another 5. So we have 10 total possible outcomes in the denominator of our fraction right now. What if I start with the number 4 from set A? It'll be a very similar situation. 4 from A plus 4 from B equals 8, 4 from A plus 5 from B equals 9, 4 from A plus 6 from B equals 10, etc. And you might start to see the pattern. Each of the 4 numbers in set A can be paired with each of the 5 numbers in set B. 4 sets of 5 will be 20 total sets. Now again, if there were 1,000 possible outcomes in this problem, that might not be the best way to think about it, but understanding that those are the basic mechanics behind even the fanciest of counting techniques will help you implement those counting techniques more logically. And I found that that is the place most people struggle on counting and probability questions. It's not that they don't know the formulas, it's that they're confused on where and when to apply them, and sometimes even how to apply them. And understanding those basic frameworks, it's just multiplication at the end of the day. Understanding those basic frameworks can really help. So in terms of this problem, just focusing on the task at hand, that gets us our probability fraction. We've got 4 total outcomes we want, the 4 ways we can make 9, divided by all the possible outcomes, including all the repetitions of sums using different numbers and the number 9 itself. When we say all possible outcomes, we really mean every single one of them, no exclusions. So that gets us 4 divided by 20, and we can then reduce that to 1 divided by 5. You may have memorized that 1 over 5 is 0.2. If so, that's great. If not, you can do some long division, and we'll have a Math Basics episode on how to do long division well linked below, in case it's been a minute since you've used that technique, and there might be some brushing off to do. And either way, we will wind up with answer B as in beta, which is 0.20. So if you're just starting out, hopefully that's a good refresher on the basics of probability and counting, and maybe even multiplication and addition in general. If you're more advanced, let's think about some possible lessons you could take away from a problem like this, other than just a deeper foundation on some more advanced counting and probability tactics. First, the most common wrong answer is option A as an alpha, 0.15. So I want you to just think about for a second, is there any way you could come up with to imagine how somebody might get 0.15 instead of 0.20? I thought about it a lot, and I'm not 100% sure, but my guess, having seen a lot of people solve a lot of GMAT problems, is that people mistakenly count the probability as 3 over 20 instead of 4 over 20, and that would be 0.15. Why might something like that happen? Well, it could just be a math mistake. We've talked a lot in this series about how to avoid those, so please check out those earlier episodes if you're concerned that that might be you. I think starting at episode 9 of this Real GMAT Problems series is a good place. That's where I start to really deep dive on how to not miss questions you know how to do and good habits for that. Another reason that might happen, you might do 3 over 20, is thinking 4 from A and 5 from B is somehow the same as 5 from A and 4 from B. That's a very understandable mistake. But just because it's the same result with similar numbers in a different order doesn't change that it's a unique arrangement. Picking 4 from set A and 5 from set B is a different situation than picking 5 from set A and 4 from set B. Now, if that was confusing for you, think about a different example. What's the difference between you paying $5 for an item and receiving $4 and change versus paying $4 for an item and receiving $5 and change? Well, that might not be an overwhelming amount of money, but a pretty different transaction in principle. In one transaction, you pay for an item effectively with $1, and in another transaction, you get paid $1 for acquiring that item. So that's a good way to think about the difference here if you were tempted by option A. So it might have just been like a little bit of a logical slip there. Another common wrong answer is C. About 5% of people are going for C. So if you think about how someone might get 0.25 instead of 0.2, you might realize somewhat relatedly to our previous topic that that is 5 divided by 20 instead of 4 divided by 20. Honestly, I'm less sure about how people might be getting there, but my guess is it's probably just a counting mistake, like they double counted something by accident or maybe even misread the problem, both of which are super, super common. So plenty of advice, again, in earlier episodes on how to avoid that kind of thing. So if you're concerned about that or you made one of those mistakes, then going back and listening to a couple of those, I'll give you some pretty detailed advice about how to keep yourself from doing that without too much effort, which is always my goal. Maximum results, minimum effort. Also, again, we'll discuss some more advanced approaches to counting questions in the future, but for now, let's just stay focused on these basic principles. I think in this problem, if you understand the basic definition of probability, again, outcomes that we want over total possible outcomes, and you understand the math behind 4 times 5 to get the denominator, you should be good to go. If you want more help with math basics and understanding the fundamentals behind this problem, like multiplication, long division, that kind of thing, we've got a whole series on every math basics topic that you would need to know to get a great GMAT quant score linked below. When you're ready, let's try another one. This is problem number 65. There's a list of numbers at the start of the problem. The list is 2, 4, 6, 8, n, a variable, 3, 5, 7, 9. That's the list. I'll read that again in a moment. In the list above, the problem says, in the list above, if n is an integer between 1 and 10 inclusive, then the median must be blank. Okay, so I'll read the list of numbers again, and then I'll read the problem again. The list of numbers is 2, 4, 6, 8, n, an unknown variable, 3, 5, 7, and 9. The problem says, in the list above, if n is an integer between 1 and 10 inclusive, then the median must be blank. Option A is 4 or 5. Option B is 5 or 6. Option C is 6 or 7. Option D, is the letter N itself. And option E is 5.5. Once again, I recommend pausing the episode and trying to visualize a solution on your own, because I'm just going to jump into my commentary here so we don't have a bunch of dead air. This is a great question to discuss an important statistics concept that comes up quite a bit on the exam: medians. You might remember that the median of a set of number is the middle number when the list is put in order. If there is an even number of numbers in the set, meaning there's no single quote-unquote middle number, then the median will be the average of the two middle numbers. If you don't remember that, or this is the first time you've been exposed to this concept, it's definitely worth memorizing both of those ideas. So let's go through them again. Couple short examples. In the set 3, 5, and 7, 5 is the median. There's an odd number of numbers. The set is in order. And 5 is the middle value. It has an equal number of terms on either side of it in the list. In a different set, 3, 5, 7, 10, there is no middle value because there's an even number of numbers in the set. So we would take the average of the two middle values, and that will be the median. In this case, the two middle values are 5 and 7. The average of 5 and 7 is 6. And so the median of 3, 5, 7, 10 would be 6. Once you understand those concepts, hopefully this problem goes pretty smoothly, but we do have 5% of people picking E as an echo, which is not the right answer. So let's clear that up and make sure you're set up for success. This might sound painfully obvious, but the first step in handling median questions is to put the list in order. And I'm always surprised by the number of people who try to get around that. And it's a very understandable belief to think like, oh, I want to save time by not putting it in order, but that introduces a ton of risk into the situation. I'm trying to think of a good real world analogy there, but that would be like, I'm going to try to steal $1 billion instead of build a business that's worth $1 billion and then sell it like very like ethically. You know, it's like, okay, stealing could theoretically be faster, but like it introduces an insane amount of risk into the situation. So it's kind of a ridiculously extreme example, but you get the idea. Like speed isn't always the desirable thing. Like speed at any cost is often not the best strategy. In fact, sometimes it's the worst strategy, and I would say that's probably true of my my recent example. If we're trying to steal $1 billion, somebody important's probably going to notice, and that might not be good. So that's a similar kind of philosophy that I'm going to recommend that you have here, which is building things the right way, even if it feels slow. It often will get you to your ultimate goal much, much, much faster. So that's what I'm going to try to help you build here as a good skill set, obviously microcosm of the exam. As you can see, the original list as presented is not in order. So let's fix that so we don't make any avoidable mistakes. A good approach here is just copy down all the numbers given the way that they're given and then cross out each one as you put the list in order in a new list below the original list you wrote. And this usually helps people from omitting numbers by accident. I've seen a lot of people try to reorder the list by looking at the computer screen and back to the scratch paper over and over again. It's really easy to miss numbers that way and get the problem wrong doing a bunch of right math on the wrong setup. We don't want that. So again, it's just about these sort of things that you wouldn't expect would be that big of a deal on a standardized test like this that end up being a huge deal. And the worst thing that can happen, and believe me, it happened to me multiple times, is like knowing all the stuff and then not having good conditioning in your process and then missing a bunch of questions you know how to do and seeing your score go down. That perhaps obviously is super discouraging. I can tell you firsthand that feels horrifically bad. And I really don't want anyone to feel that the way that I felt it. So just trying to do you a solid here and help out. So if we do that, if we wrote out all the numbers as given and then reorder them in a new list underneath, crossing out all the given numbers as we go, we'd wind up with the ordered list 2, 3, 4, 5, 6, 7, 8, 9. Just ignoring n for the moment. Now we know n, the variable, can be any integer 1 through 10. And there's a Math Basics episode linked below if you're not sure what I mean by integer, and it's okay if you're just starting out here. That is a great place to begin. So from here, it would be pretty tough to make an equation and solve the way many of us are used to doing in regular math questions. So this one's going to be more like a reasoning question that just happens to have math concepts in it, and that's quite common on the test. And in those kinds of situations, it's often a good idea to test out some possibilities and just see what happens, see if you can notice a pattern. Sometimes you notice that pattern right away. Other times it might take a few repetitions to notice the pattern. Other times you just stumble upon the answer. That's always a good thing. And then other times you might do something wrong, but then that wrong thing teaches you what you need to do to get the question right later. And I think that's a good way to think about improvisational problem solving during the exam. So it's kind of an experimental mindset that we're cultivating with questions like this, and that can be an adjustment for a lot of people who like to play by the rules, if that makes sense, or who are used to quote unquote normal math questions where the boundaries are very clearly set, and you basically start with something complicated, simplify it down, and get x equals 10, and then everything feels good. I think it's best to know that these kinds of questions can come up in advance and have a chance to practice them a little bit so that you're ready if they show up on your official exam. And of course, that's a big reason why we're here right now. So let's give an example of what that experimentation mindset might look like here. Let's start by making n equal to 1. Honestly, any number that you want to begin with works just fine, but I'm just going to start with 1. So let's figure out what the median would be if n is 1. So if n is 1, the list would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And 5 would be in the middle. It would have 1, 2, 3, 4, 4 numbers on the left, and 6, 7, 8, 9, 4 numbers on the right. So if n is 1, the median's 5. Real quick, getting ahead of not picking E and just staying safe on this problem, at that moment, it would actually be a pretty good time to look at the answers and eliminate a few. For example, the answer is definitely not E right now because clearly the median is not always 5.5 100% of the time. So I'm not saying you need to do that, but just a little tip, if you get a result in your first experimentation, you might want to check the answers and do some quick elimination just to narrow the scope and keep yourself from picking something later that doesn't make sense. So similarly, we can eliminate D because n is equal to 1 and the median is 5. So clearly the median is not always equal to n. And similarly, it can't be C because the median is 5. And you might not recall this, but option C says the median is either 6 or 7. And clearly that is not the case 100% of the time based on my example of n equal 1 and the median equaling 5. So again, not required, but it can be a helpful tactic to include in your skill set. So that leaves us with just A and B as the remaining options. And this kind of mid-problem elimination, I do want to be clear, it's not necessary, but it's a good tactic to implement if you find yourself frequently picking wrong answers or making calculation mistakes later on in problems due to either fatigue or time pressure. If you're worried that you're going to make a calculation mistake in like step 9 or step 10, you can get ahead of that by eliminating some nonsensical answers early in the problem. It doesn't always work, but it only takes a moment to check the answers and see if there's some easy eliminations. So it's a high leverage approach. It's low cost, high return. Even if we do that, though, we probably still wouldn't know whether the answer is A or B. So let's keep the experiment going. How about we try n equal to 2? That would give us the set 2, 2, 3, 4, 5, 6, 7, 8, 9. And once again, the median is 5, with 4 numbers to the left and 4 numbers to the right. Now, you might notice if we make n 3, 4, or 5, we're going to wind up in pretty similar situations. It's just going to be 5 in the middle with 4 numbers on the left and 4 numbers on the right. So even if you didn't notice that, a few more tests is likely to show you that. But let's say you did notice that and you say, okay, I want to start testing something bigger. Well, if you make n 6 or greater, that's going to change things a little bit. For example, if we make n equal to 6, we would wind up with the set 2, 3, 4, 5, 6, 6, 7, 8, 9. And now all of a sudden, 6 is the middle value with 4 numbers on the left, 2, 3, 4, 5, and 4 numbers on the right, 6, 7, 8, 9. And that's all we need to prove that the correct answer is B, as in beta. The median is either 5 or 6. So what can we learn from a question like this? Like all questions, good visual organization is extremely helpful. You might not need it, but it's a great insurance policy against missing questions you know how to do. Second, there isn't much quote unquote math to do in this question, but there's a good amount of reasoning involved. And some basic definitions like integer and median are going to be really helpful. So if you haven't memorized those yet, those are great takeaways from this problem for you. Outside of that, I don't think there's too many pitfalls in a question like this. We can briefly explore why so many people are picking option E, which is 5.5. I thought about this one a lot too, and 5.5 is the median of the original set without n included at all. So I think what might be happening for a lot of people is they're rushing through the problem due to time pressure, or maybe they're misreading or misinterpreting the question and they're not even reading the constraints of the problem at the bottom. They're just seeing the set, they're seeing median, and then they're like, cool, I know what the median of this is. It's 5.5. And then they're not even including the n variable or extra n variable. And the way the problem is originally written kind of lends itself to that mistake because you have n right in the middle. And so people are like, oh, maybe n represents the median here. And that's a really good argument for just reading the problem carefully. So maybe that goes without saying. But just in case it's helpful, I highly recommend reading the entire problem carefully. There's only millions of dollars on the rest of your career and your kids going to private school on the line here. No big deal. So if that's something you haven't been doing, it's super risky to not be reading problems carefully. And of course, everything I mentioned here is in terms of like net outcomes is only going to be true for a small subset of people. And we're all doing this for a wide variety of reasons. And, maybe nobody should go to public school. I don't know. We're not really here to debate that. But, maybe nobody should go to private school. But I'm just saying, if you want that option, this is one way that you can make that very, very realistic for yourself. So I'll never argue with your results. I just want to give this caveat. So if you're doing well not reading things carefully, then by all means, please do keep doing that. If you're getting good results, don't change. But in general, it pays to take your time setting things up and getting organized so you don't do a bunch of correct math on the incorrect setup. That's really painful when that happens. So thought I'd mention that since 5% of us actually seem to be heading down that wrong path here. So I've said this many times in this series, but imagine 100 of the brightest future business leaders of your generation in a room and 5 of them go for 5.5 on this problem. It's like, oh man, that's a lot of potential down the drain. Let's make sure that's not happening, everybody. We can do it. We can join hands and we can keep people from picking option E on this problem. Maybe that's not the impact we should be trying to have on the world, but I doubt it's going to hurt everybody. So I hope that helps. Let's do one more here. This is problem number 66. So again, this problem has a list of a bunch of numbers above it, and then there's some text right below it. I thought this was like kind of a good theme to talk through some problems that just look a little wonky, and just help you realize like they're not that bad. They're really not that bad. So what happens in this problem is you've got a list of three-digit numbers. I'll read the exact numbers in a second above a line that has an addition symbol on it. So what they're doing is they're setting up a long addition problem for you here. And then underneath that line, they tell you the result. And then there's 2 digits that are replaced with variables, and they're going to try to get you to try to figure out what those digits are, okay? So I'm going to read the actual numbers, then I'll read the problem twice, and then I'll read the answers like I always do. So the top row is 4, then the letter U, and then 7. So the number is like 417 or 427, and U represents an unknown digit. Then below that, you have N, another unknown digit, and then 23. So that second number below 4U7 would be N23. So like 123, 223, 323, 423, 923, something like that. We're going to try to figure out what those missing digits are. And then below that, you have 162. And then below that, you have the line. The result underneath the line in the result column of the long addition is 1222, 1222. So I'll read all of that again in case you want to visualize it. It's 4U7. Right below that, N23. Right below that, 162. Below the line in the result area, 1222. The problem says if U and N represent single digits in the correctly worked computation above, what is the value of U plus N? Option A is 7. Option B is 9. Option C is 10. Option D is 11. And option E is 13. Really interesting question that, as you can see, heavily tests your ability to do long addition. So it's kind of unexpected at the beginning of this process that that's going to come up as much as it does. And this is a huge reason we made that Math Basics series for you. So perhaps obviously a core skill here is going to be the basic steps of long addition. And if you want help with those, we've got a Math Basics episode linked for you below. Otherwise, the best approach for most people in a situation like this is just to work the addition problem and then do a little bit of reasoning to figure out what the missing values would have to be in order to produce the desired result. So let's go ahead and just do that together. Then we'll explore why so many people, 8%, are picking C, which is unfortunately not the correct answer. If you're familiar with the steps of long addition, you'll know that we want to start by summing all the digits in the column to the far right. If we do that, we would sum 7, 3, and 2, which yields 12. And then we would write the 2 from 12, which is the units digit of 12, into the units digit of the result. And that seems to check out based on what we've been provided here. Remember, below the result line is 1222, 1222. So we got a 2 in that final far right digit. And if we correctly worked the long addition of 4U7 N23 162 in the units digit column, we have 7 above 3 above 2, and then below the result line is also 2. And that seems to check out because if we sum 7, 3, and 2, we get 12. So it looks like everything's okay so far. Now what we'll want to do next is we're going to want to carry the 1 from 12 to the top of the tens digit column, which will help us figure out what the value of U is. So if I were to write that out, the tens digit column would have 1 from the 12 on the top, and then U right underneath that, and then 2 and 6 underneath U. If we sum those numbers, 1 plus U plus 2 plus 6, we get U plus 9. So U is an unknown. I'll just express that as U plus 9. And at that point, we'll want to do some reasoning to figure out how we could get that to line up with the 2 that's at the bottom of the tens digit column below the addition line in the result area. And in order to do that, we'll need the total sum to end in a 2. So ask yourself, what are the possibilities there? 12 comes to mind for sure, but what about 22 or 32 or 52? Well, in order to get 22, U would have to be 2 digits. So think about it this way, U plus 9 equals to 22. If we had that equation and subtract 9 from both sides, we would get U equals 13, and that's actually not possible because the problem told us that U has to be a single digit. So the only possibility is U plus 9 equals 12. And if we solve for U there, we would get that U is equal to 3. Let's quickly check that that works. If we replace U with 3 and sum the entire tens digit column, we get 12. And we take the 2 from 12 and we put that at the bottom of the tens digit column, and then we carry the 1 from 12 again, just like we did in the first step, to the top of the hundreds digit column. And that should help us figure out what N is. So everything seems to check out well there. So now, at the top of the hundreds digit column, I've got 1. Under that, I've got 4 from the 4U7, and under that, I have N from N23, and then under that I have the 1 from 162. Now that we know that 1 plus 4 plus N plus 1 has to equal 12, we can do some reasoning and figure out what N is, because that's the only way we can get 2 at the bottom of the hundreds digit column that we want, and also at the same time get the 1 at the bottom of the thousands digit column. So whoever wrote this problem was really feeling like making everything add up to 12 that day. So let's set 1 plus 4 plus N plus 1 equal to 12 and solve. Summing 1, 4, and 1 gets us 6. So we would have 6 plus N equals 12. We subtract 6 from both sides, and that yields N is equal to 6. So we have U is 3, N is 6. We just sum N plus U to get our answer, which is 6 plus 3. And we choose the correct option of 9, which is answer option B, as in beta. And while that's not the only correct path to the solution, it's a solid potential path to the correct solution. So think about this here. Any idea why so many people, 8%, are picking C? Not totally sure on this one, but my guess is people forget to carry the 1 from 12 when they correctly sum the tens digit column. That's my guess. So they wind up with 4 plus u plus 1 equals 12, and they get that n is equal to 7. And then they sum that with the correct value for u, which is 3, to get 10. I might be wrong on that one, but it seems reasonable. Like you just kind of forget about the thousands digit column there, or you forget to carry your one from the tens digit column. Either way, it's a great example of why it's helpful to be familiar with these basic operations. So again, if you feel you need some brushing up there, we've got you covered with the Math Basics series. If not, you probably didn't struggle too much with this one, and that's good news usually. So there's a bunch of problems with a bunch of lists of numbers above them. I think that'll help you just feel a little bit less stressed if you see that on the exam. I've noticed that sometimes questions like that can really get the adrenaline going for certain types of folks, where you're like, wait, this doesn't look like a typical math question. Things are getting a little bit wonky here, or maybe it's just not a question where I can set up an equation and just do math the way I'm used to. So just trying to get you ahead of the game there so that test A is hopefully comfortable, familiar, and just another day at the office. I think that's the ideal state for test A. It's a very, very familiar thing. You can just show up and do it, get it done, and get a great score and move on. That's the goal that we have for you here. So let's pause right there, and we'll pick up next time with some more practice and hopefully some insightful instruction that will help you out. If you're struggling to see results in your prep and you want some help speeding up the process, we do offer the opportunity to meet with one of our staff experts over a call and talk through your situation and set you up with a plan. There's no obligation for the call, and we will do our absolute genuine best to just help you out. No obligation, nothing weird, no catch, nothing like that. We're excited to be able to offer this service to people who are putting in the time but not seeing the results, which was me back in the day, and I really, really could have used some help with this, and that service didn't exist. And I probably spent 3 times as much time as I needed to and suffered 100 times more than I needed to ultimately get my score, which thank goodness I did, but it was really, really painful. And just looking to help all of you out. I mean, I think it's really valiant what you're up to right now, trying to grow your skills and become a better contributor and become a better business person. And I doubt that's going to fix every problem in the world, but it's probably going to fix a lot of them. Like business interests, especially big business, which is where a lot of MBAs head, has a lot of influence on the world at large. And all of you, as you become more and more successful in this process, are going to have a tremendous amount of influence. And I think that's a good thing. I think the more of you who achieve your dreams with this, and the more great leaders that we have in the world, the easier everything's going to get. That's my thesis. So. If you're just starting out and you want to be on the fastest path to success, we're also happy to advise on that front as well. We don't offer any of our paid products on these calls by default unless you specifically ask to hear about them, okay? So it's not like a pitch or like some weird gotcha moment where it's like, oh, we got you on the call and then now we try to sell you some garbage. I really don't believe in that. I know that happens on the internet a lot. So if you don't believe me, that's fine. I know it's nothing personal. What I'm offering you here is completely legit, and whether you believe that or not is totally up to you. On that note, though, if you think you might enjoy working with us directly, then you can book a call and let us know you're interested in that, and we'd be happy to share a bit about our approach and whether we think it would be a good fit for you or not. We're also happy to make recommendations and just give you options. We never try to force our thing on anybody. And if it's a fit, great, and if not, that's cool too. So if any of that sounds good, please head to our website and check out our video so that you can get a better feel for our process and how we like to do things. And then from there, you'll be able to share a little bit more about your situation and book your call if you still want to at that point. If not, it's totally cool. And if none of that sounds good, that's fine too. We'll keep doing our best to help you out as much as we can right here. No big deal, everybody. Just want you to know that that's an option if you want to take us up on it. And if you don't, and everything's going great in your prep and you're not struggling and you're getting results at exactly the pace that you want them and you don't want to speed it up, then yeah, I'm really happy for you. That was not me, and I'm glad it's you. So as always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you all soon.